Okay. All right. Hey, listen up. We're starting now. We're doing the exploration. If you have trouble finishing these, know that the exploration's not always, but I usually pull the explorations to do quiz grades. So make sure that you're following along and getting these done. If you don't get them done or need a couple more answers, I'm still recording this, and so you can get on Google Classroom later. Just go through the video just a little bit or question by question, and find out what answers I'm kind of telling you to write down, and finish it up later. Also know if you're not here or you just don't do it, and later you decide, oh, I wish I'd done that. I can't assign the explorations. They're literally always up. And so if you do it late, just send me an email. Say, hey, I got this done. I'll put it in the grade book, and everybody will be fine moving forward. So we're going to go ahead and get this going. Go into Discovery Education. Let me log into my generic account. Poor generic student.
What are we doing?
We're doing an exploration. So the reading is assigned. So you should have this mini spheres reading assigned right here. Click on the mini spheres. It'll take you into the section of the book that we're currently in. Come up to the top. You're already on the Explore tab. Click on the next page, which is Explore More Resources. And scroll down to the very bottom. And you should find the exploration. Exploration, Earth spheres. That's the section we're in. That's the exploration we're going to do. It'll open up in a new tab for you. Note, there are 2 pages for this. Make sure you do both pages. It's not a whole lot of questions. I think it's 12. But we're going to go through all of them. Make sure you answer on both pages. And I believe, unless I'm wrong, I think you have to submit on each page. You can't just submit once. It'll only submit that one page. So I will double check that and see, but I believe you have to submit both pages. So when we get done with the first page, make sure you submit it, and then we can go back into the other page. So just to go real quick through the actual exploration part, let me do this real quick. This is bugging me. Calibration, 5 points. All right, now we're a little bit better. So we have a couple spheres here. They have the hydrosphere and the cryosphere, the geosphere, and the atmosphere. And you can click on whichever one you want to learn about at the moment. Click on Proceed. It takes you to a section of the geosphere. I don't know what we're going to record here. Depth and temperature. So they're going to record the actual thermocline. So as you go deeper into the Earth, you keep recording your temperatures at the different boundaries, and they're going to give you different temperatures. And you just see that the temperature continues to get hotter and hotter and hotter as you go down. I guess that's it. Oh, I got to do one more. Now, once you've done them all, you can plot it, and it gives you your thermocline temperature, where it just keeps getting hotter and hotter and hotter as you go down in depth. So y-axis is depth, x-axis is temperature. Wonderful. Select another sphere, hydrosphere. Let's see what they got going on over here. This is going to give you salinity. So what do we click on? Atmospheric water. So you just go through each of these, and it'll build another chart for you. Salinity for all these different things. The salinity is not going to be very much unless you get to ocean water. Ocean water is going to have the highest salinity. Swamp water. Love that swamp water. Saline groundwater has quite a bit too. But yeah, ocean water is going to have 3.5% salinity. Saline groundwater has 5%, so that's actually a little bit more. And then saline lake water, this is going to be like a saltwater lake that's had water evaporate, so the salt content is going to be a little bit higher. On a little side note, an oil company I worked for got a lot of money finding salty groundwater and buying it for super cheap because we can't drink salt water from the ground. And so the people that had it didn't really understand what they were going to use it for. They bought all the land and all the mineral rights, and then they pumped all the water out in West Texas and used it for drilling rigs because out there, there's not a whole lot of groundwater out there. And bringing in trucks of water like every single day to your drill site was very, very expensive. So they kind of like mined their own water and ended up making a ton off of it. Yes. Do you have a question? All right, my bad. All right. Go to another sphere. Atmosphere. This probably won't take long either. Just record as you go up in the atmosphere. They're looking at the pressure and the temperature. This is actually going to be a little bit different. We haven't talked about this in depth yet. What happens as you go up in elevation for your temperature? Yeah, it decreases because when you get up higher in the mountains, what's the temperature like? Yeah, it's nice and cold down there, or up there, my bad. But that doesn't happen the entire way. Did I miss something? I guess I missed a couple down here. It doesn't happen the entire way. The temperature actually changes as you go through the atmosphere. And so here's your temperature left to right. The right is hot, the left is cold. And this is as you go up through the atmosphere. So yeah, at the surface is your warmest temperature. And as you go up through the troposphere, which is the lowest layer, it gets colder and colder and colder. Then you get to the stratosphere. I'm pretty sure, yeah, the stratosphere is where planes are going to fly. So they get up above the troposphere, they fly around the stratosphere, and the stratosphere actually starts to warm back up. And it gets warmer as you go up through the stratosphere. Then you get to the mesosphere, and it cools back down again. Then you get to the thermosphere, which thermo means what? Heat. So as you go up through the thermosphere, it starts to heat back up again. And actually above the thermosphere, you get into the exosphere, which is the boundary between the atmosphere and space. So like the very edge of space. And this is the pressure. Obviously, the pressure just goes down and stays down because you don't have very much atmosphere above you. Let's see. That's why the football players have to breathe oxygen on the bench in Mile High Stadium because there's literally less oxygen for them to breathe. So starting off on page 1, Earth spheres. They have a little bit of an overview. And then they get right into it and say, Earth is the blue planet. Why does Earth look blue from space? Explain your answer.
Because 7%
Yeah.
of our surface is covered in water.
Yes, it's the water. And also it does have to do with our atmosphere a little bit because the atmosphere isn't blue. It's clear, but we get that the particular frequency of light that makes it look blue. But mostly it's the water, yes. Earth is, 70-something% water? What was it? It was 71% water. So, yeah, most of what you're seeing is water at any given point in time, which is why it looks blue from space. Two, what is the difference between the hydrosphere and the cryosphere? That's pretty simple. What's the difference between the hydrosphere and the cryosphere?
Hydrosphere is like liquid water that was frozen.
Perfect. Yeah. Hydrosphere is liquid. Cryosphere is frozen into ice or snow. Easy. Easy peasy. Which reservoir contains most of the water on Earth? Where is the most fresh water on Earth located? So what contains most of the water on Earth?
The ocean.
Yes, the oceans. You said it was what, like 97% yesterday? Yeah. 97% is in the ocean. Out of fresh water, where is most of the fresh water on Earth?
Lakes and rivers.
Yeah, lakes and rivers. Okay, so for this one, good thing we went ahead and did the actual exploration because we need this for the exploration part. Or you could go in and look through the book. How much saltier is the seawater? Is seawater than atmospheric water? Explain your answer. So we come back up here. We go to the hydrosphere, and we go to proceed. We already have our charts. Let me actually go back to the tracker. It'll be on the tracker. So here's, what is this? Is this the atmosphere? Yes. So we have atmosphere right here. Salinity, where's the salinity? Representative salinity. So seawater is 3.5%. The atmosphere is 0.001%. That is a large difference. That's what, like 350? No.
What'd you say it was? 3.9.
3,500 times more, I guess.
What'd you say it was?
So the seawater is 3.5% salinity, salt, 3.5% salt, versus the atmosphere, which is 0.001% salt. Why does the atmosphere not have any salt in it? Because what?
Oh, I
All right. Yeah, because when water evaporates, all the salt is going to stay down at the bottom. The amount of salt that actually gets evaporated into a gaseous form is going to be very, very small. So the amount of salt in the atmosphere is almost nothing. So same thing with ice caps or snow or glaciers. Most of that ice comes from the atmosphere in the first place, so it's going to have about the same salt content. So how much saltier seawater than atmosphere? Give me both and tell me why there's no salt in the atmosphere. Number 5, a hydrologist collects a sample of groundwater from the coast and another from an aquifer away from the coast. He finds a major difference in their salinity percentages. What could be a possible reason for this difference in salinity? Explain your answers. Well, first off, they should have told us what the salinity was. But which one would you guess has the most salt in it? Groundwater near the coast or groundwater from an aquifer away from the coast? Near the coast. And why would maybe there be salt in the groundwater near the coast? Yeah, because the water from the ocean, the salty water from the ocean, isn't just going to stop right at the beach. It's going to soak into the ground that's right next to the coast. And if it soaks in enough, it can travel into aquifers near there. And so what could be a possible reason for this difference in salinity? You can say ocean water has soaked in or permeated or infiltrated into the groundwater near the coast, where it hasn't done that in the aquifer away from the coast. Nice, almost to the bottom. Okay, so that was the hydrosphere section, hydrosphere and cryosphere. Now we're moving on to the geosphere, and they got all the questions kind of sorted out. So, geosphere, how does temperature change with depth in Earth? Is the change constant? So, first, how does the temperature change with depth in the Earth? The deeper you go, what happens? The hotter it gets, yeah. So, the deeper you go, the hotter it gets. And then to answer the second part, we go back up, and I wish I had the charts here still. Let me actually go back and do it again. Select another sphere, geosphere, proceed. Let's just record these one more time. Because they want to know, is it constant? Is it a constant change? Or is it kind of variable? Can I record stuff in between? No. So plot this. So is that a constant change?
No.
No. If it was a constant change, it'd just be a straight line from here to there. It starts off kind of slow towards the surface, and then the deeper you get, the faster it kind of heats up until the very end where you reach kind of like a max temperature. So it is not a constant change. It's gradually changing depending on the depth. Why did I make that go down? Come on. Number 7, based on the data provided, what is the geothermal gradient? The change in temperature with depth in the top 20 kilometers of the crust. Show your work. Okay, so they probably want a little bit of math here. The top 20 kilometers is probably going to be this short little area up here. So let's go back to the chart. So if I go to tracker, here we go. Top 20 kilometers. So we have the depth. And then we have the temperature change, right? So we just do a little bit of math on this. It's not going to be too bad at all. So open up your Chromebook calculators. So you can do this. It won't be good bad. So our change from 0 kilometers to 20 kilometers is how many kilometers? From 0 to 20.
20?
Yeah, it's 20. That's the difference. 0 to 20. 0 to 20 equals 20 difference kilometers. And then what's our top temperature up here at 0 kilometers? We'll do it in Celsius. What's the temperature at 0 kilometers for my up close people? 20. And then what's the temperature at 20 kilometers? 520. So what's the difference between 20 and 520? 500. So 20 to 520 is equal to 500. So and that's degrees Celsius. So over 20 kilometers, I've changed 500 degrees Celsius. And what they want to know is, what is that temperature change on average? So I'm going to do how many degrees per kilometer. So I'm going to put the degrees on top and the kilometers on bottom. So you do 500 degrees Celsius over 20 kilometers. And that's going to equal your temperature change, degrees Celsius over kilometers. So just pop that in your calculator, and that number you get should be what you put in to that answer there. And just get it for yourself and don't tell nobody else. They can open up their calculators and find it themselves. If you can't even open up a calculator, come on. Based on the data provided, so they gave us the data, what is the geothermal gradient, the change in temperature with depth for the top 20 kilometers of the crust? Obviously, you can't really show your work on that because this isn't printed out. But that's what you're going to do. 500 degrees Celsius divided by 20 kilometers and get that answer and put it in here. I showed the work to you, so I trust that you saw it.
Okay.
In a laboratory, a geologist measures the melting temperature of iron at the extreme pressure of the boundary between the outer liquid core and the solid inner core of the Earth. What can the geologist infer from this experiment? Melting temperature to iron extreme. If we go back up here, basically what they're saying is, they don't even have it listed here. I believe this is like the outer core, and this is the inner core. What's the difference in the temperature here? Nothing. It's the same temperature, but the outer core is liquid and the inner core is solid. So why is the outer core liquid and melted at 6,000 degrees, but the inner core is solid and not melted at 6,000 degrees? What's the difference there?
The pressure.
Yeah, the pressure is going to hold it together. And so I believe that's what they're asking for. What can the geologists infer from this experiment? Because they're asking about pressure. The pressure, even though they're at the same temperature, the pressure in the inner core is enough to keep it in a solid state. Where your outer core, there's not as much pressure, so it's melted. And when you get done typing that answer, I believe go ahead and hit submit. If it doesn't work the way I think it works, then we will just have to do it. Yeah. Huh? Oh, that the pressure is higher in the inner core because it's further in. There's more pressure pushing on it. So the pressure is higher, which causes it to be solid. In the outer core, where there's less pressure, it's going to be a liquid because it's a high enough temperature to be melted. Pull your mask up, Tanner. All right. Let's see how this works. Nice. It takes you to the next page. Cool. So everybody make sure you submit. If you don't submit each page individually, I'm not going to be able to see the answers. And then either it takes you to the next page or you have to click on it. Mine's taking a little while. Your answer's been submitted. Yeah, I hope so. I'm going to grade that one, and I'll be like, who did this and didn't answer any of the questions? Because on these, like on the other assignments, it didn't let me do it. It just shows me y'all's names. But on these, I have the option to hide the names and grade them, and then release the names so I can see who it is. That's how all online grading should be. I don't see the names. I just grade the answers. All right. So now last couple ones, 9, 10, 11, 12. This is about the atmosphere. So number 9, describe in general how temperature changes with altitude and the atmosphere. Is the change constant? That's a little bit more complicated. I would say in general, so let me go back to this. Atmosphere, proceed. It's going to get colder as you get higher through some ones. I guess let's just break it down. So as you go higher, I would say your temperature drops. Your temperature drops in the thermosphere, but then rises in the stratosphere, and then drops in the mesosphere, and then rises in the thermosphere. Because you can't even say that it gets colder the entire time in general. It doesn't get colder the entire time in general. And so it goes down, it comes back up, it goes down, it comes back up. The second part of that question was, is it a constant change? No, it's not. It goes down and it comes back up. So in general, how temperature changes with altitude in the atmosphere. So as I go up from the ground, my temperature is going to go down in the troposphere. So the troposphere is the bottom layer that we live in and do all our stuff in, except for fly airplanes. It's going to go down in the troposphere, up in the stratosphere, down in the mesosphere, 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 and then up in the thermosphere, which makes sense because thermo means heat. It's going to get hotter. Okay, number 10. Which layer of the atmosphere do airplanes usually travel in? Why do you think this is so? I'm pretty sure it's the stratosphere. Let's see if they actually tell us in the reading. Unless I just remember completely wrong. I'm pretty sure they get up in the stratosphere. Let's see. This is water. The atmosphere. Atmospheric gases, biosphere, what? So they don't talk about it. Importance of Earth's atmosphere. No, they don't even talk about that. So why? Why do the planes? So give me a second on that. I know it's the stratosphere. Well, I'm pretty positive that it's the stratosphere. Why do airplanes usually travel? At which layer, and why do you think this is so? But why? Why? That's the most important question for anything ever.
Because it's giant.
Because what?
Because it has fewer clouds or mountains.
That would make sense. So yeah, you're gonna have less turbulence because you're in a more stable air package because there's less clouds. So yeah, good. Did you Google that?
Yes.
Nice. Google's always your friend. So yeah. So the answer was, why do they travel in the stratosphere? Because there's less clouds, which is going to provide better flying, less turbulence. If you've ever been on an airplane, sometimes you get that turbulence going on when you're in the cloud layer. So they say that over here.
Nothing more annoying when people on airplanes get like scared by turbulence. Which
Yeah.
on every flight.
It does happen on almost every flight. That being said, I completely like understand the people that are afraid of flying because we're not supposed to be up in the air like
But
that. Yeah.
planes are actually safer than cars.
Oh, they are. But it's not like nobody dies in planes. But
But
yes,
it's not like
it
nobody
is.
dies in cars.
I know, yeah. And we don't like get in every day before we leave for work and like do the prayer and be like, oh, let me get to work and safe. We just like trust that we're gonna drive ourselves. But yeah, the people. I just don't like the people who get nervous on flights because they make me more nervous because they're over there like gripping the seats and they're like, oh my god, and I'm like, I wasn't afraid until you started to freak out, and now you're making me nervous. And like when I was younger, no, but like I guess we all just took it for granted. And then I think maybe it happened after 9/11. Now I don't fly a lot, so this is like not a normal thing. But every flight I've been in post 9/11, everyone claps when we land. Like it's like yeah, we got here safe. Oh, thank you, pilot. Thank you.
I've never had that happen.
You've never had that happen? Has anybody had that happen other than me?
All 3 times that I went to Vegas.
See, they clap. Yes, it's so maybe it's just whatever flight you happen to be on. But it's a thing that some people do now. They're like, we got here safe. Oh, thank God. So it is a little bit weird when it happens, but also they did get you there safe. They have everybody's lives in their hands. Pilots do. So identify the layer present in the stratosphere, which makes the stratosphere one of the most important layers of life on Earth. Explain your answer. Anybody have a guess to what this is?
It's where the ozone.
Yes, the ozone layer. Is that what you were gonna say?
Yes.
I don't believe you with your yes. But yes, it is the ozone layer that's in the stratosphere. And what does the ozone layer do? Yes, protects us from the sun's radiation. So specific rays in the sun's radiation, probably UV rays and a couple others. Does anybody happen to know exactly what ozone like is? Yes, it's like oxygen with an extra oxygen. So instead of the O2 that we breathe, it's O3, which I don't think is good for us. Yeah, like when you have ozone days, there's ozone days where the ozone is weak and you're getting more radiation, and there's ozone days where the ozone is like lower, I think, and we have more ozone. I might be wrong about that, but yeah, too much oxygen is a bad thing. We like that 30%. We're nice and happy with that. In this exploration, graphs have been used to represent the recorded data. Use an example from the exploration to explain how graphs help make analyzing data easier. What? I mean, graphs they show you things. What do you want from me here? Yeah, let's just omit that one. I mean, like we all know what graphs do. They visualize things for you. Maybe like in the atmosphere one, you wouldn't know that it goes. I mean, you see that it goes up and down. What? Number 10. Let's see. If you wanted to answer that one, you could just say, I hate reading numbers and graphs allow me to not read numbers. Huh? Oh, it's okay. I mean, it's if you omitted it, it's fine. Which layer of the atmosphere do planes usually travel in? The stratosphere. And why? Because there's less clouds and there's going to be less turbulence, so you can get there. A little side note. I had a teacher who's a coach, and don't get me wrong, you can have great coach teachers. So don't just go tell your coaches that Mr. Bailey was ragging on coaches. But I had a coach that tried to explain to us, I don't even know what class it was. It was a general science class or something. I don't know. He tried to say, because the earth was spinning, when a plane left the ground, the earth spun underneath it, and the plane could only go in one direction. Because you can't like outfly the spin of the earth.
That makes sense.
No, it didn't. And like I think it was probably junior high. Even like a classroom full of junior high kids was like, no, that's not right. And he's like, yeah, no, it's totally, the plane goes up in the air, the earth spins. You can't fly faster than the earth spins because you can't fly around the earth in 24 hours. Huh?
You were saying that you were in one spot?
No. Well, yeah, I guess if you flew the other way, that you would either stay in the same spot or you would go backwards maybe. But yeah, he was trying to say like in order to go just like a little hop in one direction, you'd have to either go like all the way around the world or like go up. I don't know. It was a terrible explanation, and I remember it being like one of the dumbest things I've ever heard. And the whole class was just unanimously like, no, that's not how it works. Like, we've taken flights to the other direction. But sometimes you justify things in your head. You can convince yourself that you got it right. But yeah, he was a coach. He was a good coach. I like the guy. He wasn't a bad guy. He's our bus driver too. Which I don't know. Like today, I don't know that coaches and bus drivers could be the same thing. Because do y'all have coaches that are bus drivers? All right.
Yes.
Just when they're in season, they have somebody else
Okay.
that does it after school.
Okay, maybe that's what he did too. Yeah.
Yeah, he's racing. We had one
No,
right
Yeah,
dude,
yeah.
I was gonna ask when he got done with it.
You
Can I
can-
go when he's back?
when he's back, I think he can.
Can I go?
No.
Yeah, we ain't having no parade.
Yeah.
No.
I'm autistic.
No, you're not.
All right.
What?
So if anybody have any questions, let me know. Make sure you submit the second page too. Don't forget to not submit the second page. And if you didn't get it done or you'd like to finish it up